I think that's more valuable to be here.
We're trying to save you, David.
Yeah.
I say those jokes like I say those jokes. A lot of people I know say those jokes. It's just
No, David.
I don't think so.
It's
I don't think it is.
well, nobody in this class. Like like everywhere else I go.
Where do you go?
McDonald's. Okay, we're going to get started here on this next chapter. We're going to get into functions and then also graphs of functions. Today we'll talk mainly about like what makes something a function, how do you work with function notation when you're trying to evaluate something. So we'll talk a little bit about what a function is, specifically with like the domain and range of a function, be able to evaluate a function at a given point. And then we'll also talk a little bit about the graphs and something called the vertical line test. So the first thing I want to go over with you guys is what domain and range would be. So domain would be all of the x values that you would have on coordinates that maybe make up your function. A function is just like a fancy way of saying it's an equation. So instead of saying y equals something, we'll use function notation. And function notation looks like this, where you have f parentheses x, but we say f of x. You saw a lot of that last year in Algebra 2 when we were working with functions and graphing and doing compositions of functions and all that stuff. But instead of saying y equals, we start to use this notation because in the case that like I was looking at a lot of graphs at the same time, if they all said y equals this, y equals that, y equals this, it would maybe be confusing for someone who sees a lot of y's and then they're trying to figure out which graph or which line is she talking about. If I say f of x or g of x or h of x, it kind of distinguishes like f of x goes to this one and g of x goes to this one. Just offers a little bit more clarity on a picture that maybe you're dealing with a lot of different equations. So that's why we use the notation. But like I was saying in the domain, that would be all of your x values. So I would just write that after that because they kind of talk about it as far as ordered pairs go, but we're going to think of it as what are your x's, and then the range would be what are your y values. So all of these functions are going to be consisted of points. You're going to have ordered pairs that are making up the equation or the graph that you're working with. And so we need to be able to identify what's the domain and what's the range. So that's what we're going to do first. All I want us to do is write out what the domain and range is here. So to shorten it, I'm just going to say D for domain. And I just need to write out the numbers that are all of my x's. So in that first coordinate, it would just be 5. What would be the next x? And the next one? And then the last one would be 8. Okay, so that'd be all of your domain values. We do the same thing for the range, but we take our y's. So 3.4, 2.3, and then what? Good. So that would be your range. And we'll be getting in a little bit more too of when you look at a graph, being able to write out the domain and range every time so that we can just kind of state what numbers would work for our equation versus which ones maybe we can't have. Because we'll get into some cases where you can't just have any numbers that you want. There's going to be some numbers that cause issues with equations. Now, to decide if something is a function or not, we can look at the domain and the range and kind of recognize there's some kind of like pattern happening with the numbers. Like we would call it maybe a mapping. And even when you guys were in geometry, you talked about functions and you talked about mappings and like being able to see, okay, these points all go to these points. And then we started talking about it in the geometry sense. But when we think about it in algebra, what makes something a function is that every element in your domain, so all of your x values, only go to one element in the y column or in your range. So we need to think about it like this. You all, right now, we could all be considered like x values for a function because we can all go to different places throughout our day. Okay, some of you in the last period, you had class together. And then you all came to my class now together. And that's okay because we're all here together in Algebra 3. But is it possible for you to be in Algebra 3 and be in your English class at the same time?
No.
No. I don't teach you guys English, okay? And your English teacher isn't teaching you Algebra 3. So it's not possible for you to be in those two classrooms at the same time. You have to pick where you're going to go. And so I want you to kind of think about that when we're looking at these values. Are there X values that are trying to almost split themselves and go to two locations at one time? And that's kind of what we're talking about here with the idea of if it's a function or not. So what I like to look for is when I'm looking at my coordinates, I check all of my X values. So I have a 5, a 6, a 2, and a 7. All of those X's are different from each other, so it should be a function. So I'm going to go ahead and say all X's are different. Therefore, yes, it's a function. Does that same thing happen on the second example? Is there an X value that gets repeated?
Yeah.
Which one? The 5 does. Okay, 5 is here and it's here. Okay, because those are the same, this is not a function. Because I want you to kind of follow along here. I'm going to write out my X values. So I have a 5, a 6, and a 2. And I'm going to put them in order. So 2, 5, and 6. Those are my X values that I'm given. My Y values that I have a -3, I have an 8, and I have a 9. Now, it kind of maybe looks right now like this could be a function because it looks like there's only one. I only wrote 5 once, and I only wrote the 8 one time. But if I actually start to draw in what we would call like the mapping, like connecting where they go, 5 would have an arrow to 9. 6 would have an arrow to 8. 2 would go to -3. And then 5 has another arrow coming off of it, also going to 8. Anytime that an X value has 2 arrows or more arrows trying to come off of it, that's the same idea as like you and I trying to split our location into 2 places at one time. Okay? I can't be at home and be here at school at the same time. I know, sadly. I have to choose. Am I going to stay home today or am I going to go to work today? Okay? So that's kind of the idea behind what makes something a function or not. All right, questions about that? Okay, let's turn the page over. So sometimes they'll want us to look at equations and decide if it's a function or not. So instead of giving you a whole bunch of coordinates, they might just give you an expression for this specific situation, and they want you to understand if it's a function or not. So if an equation is solved, so if we're putting numbers in for like our X value, and more than one value of like what if we can get to the same answer more than one way. So if I plug in an X value and I can get 16 to come out 2 different times using 2 different X values, or using the same X value and I get 2 different answers to come out, that's going to cause issues and it's no longer going to be considered a function. So think about the example. If I had y equaled plus or minus the square root of x squared. Now the square and the x squared kind of outdo each other a little bit here. But if we think about putting in a number for the x, so if I wrote this as the square root of 9, and I think about this, what's the technical answer here for the square root of 9?
3 plus or minus 3.
Yeah, plus or minus 3. So this means that if I put a 9 in for my x, I got 3. Or if I put a 9 in, I got -3. So that would be an example of not a function because I was able to put 9 in and get 2 answers to come out. And I could have done that for really anything. I could have put in any number that I would know I could maybe easily square root, or even the ones that you can't square root nicely, and I'm still going to know that there's going to be a plus and a minus option there. So that's going to cause issues. So when we see that, we want to also just kind of take a look at these other examples to understand how this would relate to those as well. Okay, so for example, this next one says x squared plus y squared equals 1. I like to keep it simple if I can when I'm putting numbers in to like see what would happen. So I'm just going to think about putting in a number for x and in for y. Now what I would do first is solve for y. So I would get y by itself in this equation, just so it makes it a little bit more isolated on where I'm plugging my numbers in. So I'm going to start by subtracting the x squared. So this would then say y squared equals negative x squared plus 1. And then how would I get rid of the squared? I'd have to square root it. So this would say y equals the square root of negative x squared plus 1. I'm just going to leave that under there for right now. If you square root something, though, how many answers do you get? You get 2. So if I started putting in numbers for x, I could get the positive side or I could get the negative side. So this is another example of this wouldn't be considered a function because there's going to be 2 possible answers that come out when I plug in a single x value. So I would say, again, not a function. So think about it as any time that you can put in a number, and if you're going to get multiple answers that come out. So if there's a plus minus sign in front of it, or even think about like maybe the 4th root of something, that's going to start to cause issues and it's not going to be a function. If it's just like an x, there's no square root sign or anything like that, it's like linear or something, that's going to allow you to say that it's a function. Okay, this next piece I want to talk about is evaluating a function. So they're going to give you the function in the notation form, and they're going to give you a number that they want you to plug in for your x and just evaluate. So they'll write it like this over here. See how it says f parentheses 2? It's similar to that f of x notation we talked about at the beginning of the notes, but in this case, 2 is what you're going to put in for your x. And so you can kind of see 2 got put in for the x here next to the 7 and in for the x squared. They also are writing it after the f because they're just writing out like we're evaluating this function for this specific value. So we're putting in the 2. And then we just kind of follow what they did. They did 2 squared minus 7 times 2 plus 6. And then they just did the math. So 2 squared is 4. Negative 7 times 2 is negative 14. And then plus 6. And then they just added and subtracted those things together. So they did 4 minus 14, add 6, and they got negative 4 for their answer. So it's like what we did on our bell ringer today. If you're plugging in a number for x, it's just written differently because we have the function notation now and not just saying y equals this equation, plug in this value for x. You're kind of recognizing that f of x means the same thing. Okay, why don't you guys go ahead and try the next one? Okay, so that's what I would have plugged it in as. So that's kind of what it looks like here. Then I would have just started to simplify this. So it should have been 25 plus 10 plus 7. What'd you guys get? 42. Now, technically, these are coordinates. So someone might write the answer as negative 5, comma 42. Because you put negative 5 in for your x, you got 42 out for your y because that's your f of x piece. So just know that they might write it as a coordinate, especially if we're starting to think about what this would look like on the graph. Okay, now I would probably not expect you guys to graph a point like that, okay, because you wouldn't have a lot of space on a typical graph that you see. But we are going to get into a little bit of the graphing now. So if you guys go to the next page, we're going to talk about graphing. And if you didn't grab a calculator when you walked in, I would go get one really quick because we're going to use the tables on the calculators. And we've done this before. Like you guys have used the tables last year in Algebra 2 when you were getting quadratics and stuff like that graphed. So I'm just going to kind of refresh your guys' memory on how to do this. But I'm giving you kind of the outline for a table, and I want you to plug in this equation for your table value, and then I want us to fill it in. And I always tell kids, like, get some negatives and some positives. Now, if you have really large numbers and you can't fit it on your graph, just be wise with what numbers you're trying to pick. Pick the ones that you're going to be able to fit on your graph and like give a good picture of what's happening here. So I'm going to walk you guys through again how to do this. So on your calculator, you should press the table button. And it'll already probably say y equals, or it'll say something like that for you. Remember, y just means f of x. So up here where we see f of x equals x to the third minus 1, that f of x is just being replaced by a y right now. And then you type in the equation as it looks. Okay, to get that 3, you're going to hit your x key, which is right here. Your x key is right next to the 4. And then to get another exponent, make sure you use this caret key. Like right up here, it's like diagonal from the 7. And then you should be able to type in your 3. And that should get it up in that exponent spot. And then you're going to hit minus 1. Make sure you do subtract 1. Sometimes kids will accidentally type in a negative, and then it won't like work for them on the table. So if you ever have that where you have something with a minus sign in the equation and it didn't go in correctly, then you want to make sure that you go and check that you didn't use the wrong symbol. Okay, and then you should be able to like enter through all those options. Like don't change anything about the options, just go straight to your table and go ahead and fill that table out. Put some positive and negative values in there. And you don't have to fill out the whole table. Like I'm just going to go -2 to +2. Can you guys tell me what my numbers would be on the y column?
4, 1, 0, 1, 4.
I don't think so.
No. -9, -2, -1, 0, and 7.
Yeah, that's what I got. Did you put into the third?
Well, it's because I put it to the third, but from the exponent I subtracted 1.
Oh, yeah. Yeah. Okay. That happens too. Make sure, when you have those exponents that you get out of the exponent before you start typing other things in. Good. Okay, so let's go ahead and graph this. So -2 down here, negative. Wow. This is not a great graph. You can barely read those numbers. Okay, so that's what that should look like. Kind of almost like an S shape. That's going to happen when you have x to the third. It's going to make that shape of a graph. Okay, so now let's do the same thing over here on this one, but let's change our equation. So this time it's a -x to the third plus 2. So again, I would go to your table and I would type this in, -x to the third plus 2. And I would do the same set of numbers, -2, -1, 0, 1, and 2. What do we get for those?
10, 3, 2, 1, -6.
Everyone got that? Okay, and then we're going to graph those. So they look similar, like they both kind of have that S shape. They are a little bit different in just where they're placed on the graph. And a lot of that comes from the fact that the left one says -1, the right one says +2. So that is going to change where the vertex goes. It's going to affect it moving left or right. And then that second one also says -x to the third. So that's going to cause it to reflect. So they are going to be a little bit different from each other there. All right, questions on graphing those things? Okay,